Well, good morning to you. As Gareth says, this has all been very interesting. It's all been about the engineering, but there's no point having a supercharged engine if you put poor quality fuel into it. So what I'm going to do is just tell you a little bit for a few moments about the biomass, the wood chip that has gone into this lovely boiler. But it isn't just about the wood chip, the quality of the wood chip. It's also about the service provision that comes with it. So that's what I want to talk about. So let's just have a look at wood chip or biomass in general, and I'm going to give you some exhibits here. So it might be that you think that you want something like this, some nice, lovely wood chip, but because you don't specify to your producer what it is that you want, you end up something like this, that you actually got to put a shovel into in order to move. It's been stored out in the wet, it's gone moldy, it's gone claggy, it's not going to go anywhere, and it's not going to produce much energy. But it's not just about the chip themselves, it's how big they are. Is this sort of thing going to rest across an auger and get jammed in the system, bridge, cause problems with obstructions? So that might have burnt quite well in an open fire, but it's going to cause problems with your reliability and continuity of supply of that heat. And in a place like this, where the production of the heat is absolutely crucial for keeping the university warm, if there are any obstructions, any problems that cause a blip in that continuity of supply, then that causes a major problem. And besides from that, it's very expensive in terms of time for the operator and for the engineer, etc. So you might end up with lumps like this, or you might end up with bark. Bark could be chipped down, it might look nice, it might look the same size as wood chip, but in actual fact, the naughty elements within the wood, the nitrogen, the chlorine, the sulfur, and the ash, generally speaking, there's 10 times as much in the bark of a piece of wood than there is in the core or the heart of the wood. So therefore, we have to specify the wood. And as you can see, it could range, and you might not see that picture very well, but that's of a circular rotating materials handling device that screws the wood chip into a feed auger. It's not on this system, we don't use it on the Cranfield system, but you can see what's happened because of the wet wood chip. The wood chip is actually stacked, and the machine is just rotating without actually gathering more wood, so that causes a big problem. That's the ideal, that's what you're looking for. That's going to be made out of log wood like that. So we need to specify what that wood chip is going to be made out of. If we talk about wood chippers, people might think of a wood chipper like you might have at a garden or whatever. Yes, that's a wood chipper, but because it's low power, it's got a very fine cut. The wood chip that comes out of that is almost like little shavings, and it would be no good to us here. So you might go for a bigger wood chipper, but then it comes down to the source of the material. So if he's chipping straight green material with a lot of leaf, a lot of twig, he's going to get a lot of nitrogen, he's going to get a lot of chlorine, and that's going to cause problems to the quality of the material in terms of its burning quality and the emissions from the boiler. And the final one here, if you can see it, that's actually of a little brush that's been sweeping up some dust on the floor of a wood store. And if you want to know more about the problems of dust, go on the internet and type in Avonmouth. Although that's of actually waste wood, they had huge problems with dust, and there are question marks on dust being a hazard to health. But worse than that, if you have a dusty environment in your fuel store or within the whole of the building, then that dust at a certain concentration in air can actually be explosive. It will explode as if it was a gas mixed with air. So we don't want dust. So within the specification, there are guidance notes which will advise us about how much dust there might be, and they will classify that as the fines content of less than 3.15 millimeter. So to the one extreme, we've got the fines content. To the other extreme, we've got those large lumps of wood. And in the middle, we've got a normal distribution of a spread of sizes, and that's what the classification will actually guide us on. So in the old days, it was G30, G50. What that is telling us is what the larger end of the normal distribution curve is, and that 60 or 70% of the material will be within the bulk of that distribution, and there will be these fringe elements with very small quantities of fines, and there'll be limits on the length and of the size of any chunks or lumps of wood in there. So if we go into the detail of that, going across the top, you've got the origin. The specification standards will talk to you and they'll suggest that you identify the origin of that wood. Is it coming from abroad? But is it coming from a woodland, or is it coming from a wood yard where the timber mill is making core wood into planks, and you're going to end up with what they call the slab wood, which is basically a little bit of wood with a lot of bark around it. So the origin of the wood is very important, and the standards that we'll show you in a minute will tell you how to explain and describe what the origin needs to be. The supply chain. The supply chain is important. How far has it got to come? Carbon miles for transporting in. What are the activities that are going to happen to that wood as it's chipped? Maybe it's dried, maybe it's air dried just on the side of the forestry, or maybe it's air dried using ambient air on a ventilated floor, or maybe it is warm air dried or even kiln dried material for when you get down into the very high grade domestic type wood chip or pellets. So the moisture content's very important. I think probably if we'd have asked, what do you think of when you think of the quality of wood chip, most people would have jumped and said, well, the moisture content is critically important. So we'll come to that in a minute. The density of the bulk density is very important as well. So what happens to the wood when it comes through the supply chain is important. Depending on the size of the chip, depending on what the nature of the material is, you could change the bulk density, and with that indexes to more wagon loads or bigger stores for holding it. For example, miscanthus or straw as a biomass take up a lot more volume. They need much bigger feeding in equipment to feed a boiler, and there are other issues with those. Particle sizes I've alluded to, that in the specification it'll tell you about the G30, G50, G100. But I'll show you in a minute that those standards have come from the O-norm system, and so in this country now we're moving on to a British standard which roughly equates to the O-norm standard. Chemical content in the wood, measured on the dry matter of the wood chip, is critically important. I mentioned that more of the nitrogen, the sulfur, and the chlorine is actually gathered up within the bark of the wood. Therefore, the heartwood is the good stuff, and that's what you really want. But these contaminants, these chemical contaminants, index to the emissions from the flue stack, from your boiler flue. So the nitrogen index is to NOx, all of the oxides of nitrogen, the naughty ones. Sulfur dioxide is called the SOx, and the chlorine is connected to dioxin emissions. So the quality of the wood going in and the type of boiler you've got will influence what the levels of emissions are at the flue stack. So buying in the quality of wood is important to whether you're going to cause an environmental problem or need a permit or continuous monitoring on your flue if you have those sorts of materials in the fuel. Calorific value, very important. It's for most organic materials, the calorific value done on a dry matter is very, very similar, but there are small and subtle differences between hardwood and softwood, and differences again to other things like straw, miscanthus, and so on. So there are subtle differences on the basic, the net calorific value, but what we're interested in here is that this material does achieve a standard for calorific value that we then adjust depending on its moisture content and its ash content. So if you've got a wood chip with a lot of ash content in it, i.e. that's the material like silicates that aren't going to burn, then that percentage of ash is of no use to you, so you're paying for it, but it's not going to produce you any energy, but it's also displacing energy content that would have been in the rest of that wood. Ash content is very important, but in our instance, it's more important to do with the ash handling within the boiler. So if you have too much ash, that can blind up the air pathways within the hearth of the boiler, and therefore produce a poorer burn. Also, you've got the de-ashing system, the de-ashing augers, etc., need to handle that quantity of ash. And if you have high ash materials, then you need to be thinking about a fluidized bed or a shaking grate or something else which can actually handle that level of ash content. And finally, you've got to pay for that ash to be removed at the end of it. So therefore, ash content is important, but we're quite lucky with the clean sort of fuel that we have, that isn't too much of an issue. And then there are contaminants, such as physical contaminants, old boots, stones, aggregates, chip-ins that have been raked up with some loading shovel maybe, and other contrary things, Coca-Cola tins or whatever. So there's quite a lot to think about. The key, as I said, most people would think of would be the moisture content, and I put a very simple illustration up here, basically of a wet wood chip and a dry wood chip. And what I'm trying to say is that if the moisture content is 60 to 65%, then you can't burn water. That water needs to be removed. It needs to be converted to steam, water vapor to allow the rest of the wood chip to do its function. And it means because of that extra water in there, you've got a lesser fuel value within the wood chip, but you're also going to waste some of the fuel that you've got in burning off that excess moisture. So therefore, if you go for a drier wood chip, then much more of it is going to be available to convert into readily available energy. So moisture content not only affects the net energy, but as you can see from the samples that I've got here and from the earlier slide, moisture content will relate to spoilage, so you get fungal growth, that sort of thing. So that's bad anyway from a health point of view, but also that will cause the wood chip to bind, and when it binds, it won't fall, it won't flow easily. So therefore, it's going to be problems all the way through the flow system, whether it's elevators, conveyors, falling into hoppers, and then an auger at the end. So that high moisture content is going to cause problems all the way through. So drier chips also mean higher energy density because you're not lugging the water around, so we're saving on carbon miles for carrying water that we didn't really want, so somebody else can dry it somewhere else in a more efficient system. And it also means that when it's in the store, we need a slightly smaller store because it's more intensive energy there. And also when we're feeding it through into the boiler, then the machinery and equipment can work easier because it hasn't got to move so much volume of wood in order to produce the energy that we want. So the standards now that you need to be looking at in order to specify is the BS EN ISO 17225, and these versions are 2014 versions. I have to say that when we first started the exercise, we were working on the 2010 versions. There were predecessors of those with documents from Europe, and the predecessors of those were the O-norm standards that we still talk about, and the engineers amongst us still talk about the O-norm, the G30, G50. In these standards, they use slightly different terminology, but we're still talking about a particle size curve in a normal distribution with certain limits, P60, P100, whatever, and they will give you guidance on how you specify for the required moisture content, the required ash content, all of the trace elements, and so on. What you'll find is that these British standards come as a family. So you look for the part 1, gives you the general requirements, and although you have to pay for these from the British Standards Bookshop, they're excellent references because at the back of them they give you examples of lots of different types of wood, whether it's clean forestry wood, whether it's hardwood, softwood, bark, whether it's forestry residues, and they give you the analysis and the typical calorific values, and the nitrogen and the chlorine and all of the other tests that you would need, as well as telling you all about how to specify the actual wood chips or any other biomass. But together with that, you now need the part 4, which is the one specific to the wood chips, and so that will guide you very precisely as to what how to specify your wood chips. More than just talk about the quality, they also talk about the origin and supply of the material. So there's a coding system that you can actually use to refer to say, this is the origin we want. It needs to be clean virgin wood from whole trees without roots. Somebody else might ask for something different. So there's a way of specifying that. So those are very important, and that's all about the quality right the way from the source and origin of the material. But as I've said at the very beginning, it isn't just about the quality of the wood chip, because if the lorry doesn't turn up, Gareth, then if the lorry doesn't turn up, then you've got no heat, no matter how wonderful that wood chip is. So we went out to tender under a separate tendering exercise to the one that Sam was talking about for the wood chip supply. And we talked to dozens of different companies. We set out a tender document. We gave them every bit of information that we could, including diagrams, plans of the site, turning areas for lorries, the whole works, so that we could get the best quality bids from them. We had to sift through those. Maybe we had to say no to some of them. Some of them didn't come up to the standards that we wanted. And we were looking for service excellence. And I'm pleased to say that that's what we have got. So we had to write a draft supply contract. So that's a wood chip or biomass supply contract. We used an example template from the Carbon Trust website, but we modified it quite a bit to include things that we wanted worked in there, things to do with the what-ifs. What if something doesn't work? What if something goes wrong? And there were a few other things like the requirement for health and safety built into it. And that contract document becomes a point of reference. It becomes something that we can go back to. We hope they don't need to, but if anything crops up that we need to talk about with the supplier, we can go back to that document and say, look, we agreed in here that you would do this, that, or the other, or you would look after the health and safety, or we'd look after, who's going to look after the testing of the material? You are, we are. It's in that document. So that document talks about the wood chip quality, of course, but it talks about the continuity supply. Is that supplier going to still be in business in 3 years' time, 5 years' time, 10 years' time? What about traceability? How can they demonstrate to us that that wood has actually come from the source that they've told us about? How far away has it come? How many carbon miles has it done? What is their service quality? How are they going to work with us? Are we going to have regular meetings? Are they going to talk to us and exchange? And if there's a problem, they will tell us straight away. If we've got a problem, they'll see if they can help us. And then, of course, there's the price and all of the issues that go with the price and the fees. Are we going to split out the transport costs from the actual wood chip price, or are we going to put them all together and say, look, it's a one-off price per ton delivered or per cubic meter delivered? Some contracts work on per unit of energy delivered. So what I've done is I put together my 10 keys to what needs to be in that contract document, in that specification, that all of that information that each party is going to sign up to. Things like, how are we going to call off the next load of wood chip? So notification to supply. Are we going to telephone them? Are we going to send them an email? Is there a magic eye or a magic camera within in the store? Or does the machine within the store profile the heap and says, yeah, I'm getting a bit low, and it automatically sends a signal? That needs to be thought about. The delivery window. Do we want them to come before 8 o'clock in the morning because there's lots of traffic on site? When do we want them to come? How soon after being called off should they come? Non-delivery. What happens if there's a problem, a delay? They're caught in traffic. What happens then? Accessibility. Can the lorry actually get into the site past parked cars? And has it got enough room to turn and reverse into the building? Offloading issues. The size, the capacity. What about cleaning up afterwards? Those sorts of things. Specification check of the material. Who's going to take the sample? How often they're going to take the sample? And who's going to send it off to the laboratory to check that it's within specification? The origin and continuity of the material. Always keeping an eye on that. If they have to change their source, where is it coming from? And they will keep us up to date with that. Regular meetings to review. We can't overstate that. It's been fantastic, the meetings that we had with the supplier, and they're keeping us up to date with how things are going. Ordering in advance. These suppliers have to order their timber, if you like, their feedstock, like nearly 1 season in advance of when they're going to supply it, so they can air dry it, chip it, store it, dry it on their drying floor, and have it ready for us for the next winter time. Price factors, indexing. The price factors are things, what if the moisture goes out of the range that we specified? What if there's another issue to do with the price, or if there's a delay, or what if we've got an obstruction in front of the building and they can't tip and that holds them up for an hour? We had to think of all these things, and so we put them into this contract agreement. And then, of course, terms of how we'll come to the extension and renewal, and we'll be talking about that sort of thing well in advance of the end of the contract, again, because they or somebody else would need to plan ahead for supplying us with the wood chip. So there's lots of things to go in there, and I'm just about done. I see the Gareth's giving me the little red light there. So thank you very much for listening to me. But remember, it's not just about the wood chip quality. It's about the whole service and supply. Thank you very much.